Hello student, in this lecture I will discuss transient response of second order system. So let's start our discussion. See, the general expression for the transfer function of a second order system is Cs by Rs is equivalent to omega n square divided by s square plus 2 zeta omega ns plus omega n square. So this is the standard form of transfer function of second order system. Okay. Here omega n is undamped natural frequency and zeta is the damping ratio. Okay, and Rs is our input, Cs is our output. So this block diagram represents the second order system. Okay, so here Rs is our input, Cs is our output, and our gain Gs is equivalent to omega n square divided by s into s plus 2 zeta omega n. And here I have considered unity feedback system, so Hs equal to 1. Okay, so this block diagram represents the second order system. Okay, now see the characteristics equation. We have already known the characteristics equation is nothing but the denominator of transfer function. Okay, so here the denominator of transfer function is s square plus 2 zeta omega ns plus omega n square. So this is our characteristics equation, and we have already known characteristics equation is equivalent to 0. Okay, so here s square plus 2 zeta omega ns plus omega n square equal to 0. Okay. Now here we have taken a mechanical and an electrical second order system. Okay, and here I have derived the transfer function of these two systems. Okay, so these two systems are second order system. Okay, so now see the electrical system. Here I have taken RLC circuit, simple RLC circuit. So if we apply Kirchhoff voltage law at the input side, then we can write this equation VIT equal to RIT plus L DIT dt plus 1 by C integration of 0 t IT dt. Okay, so we need to find out the transfer function. That's why here we apply Laplace transform. So after applying Laplace transform, this VIT equal to VIS, and this VIS is equivalent to RIS plus L SIS plus 1 by CSIS. Okay, so after taking the common IS from this equation, we can write IS equal to VIS divided by R plus LS plus 1 by CS. Now we write the output equation. So from output, if we apply KVL in output side, then we can write V0t equal to 1 by C integration of 0 t IT dt. Okay, so after applying Laplace transform, we can write V0s equal to IS divided by CS. Okay, now we put the value of IS in this output equation, output transform equation. So after putting the value of IS in output transform equation, we can find V0s equal to VIS divided by CS into R plus LS plus 1 by CS. Okay, now we calculate the transfer function. So transfer function is nothing but output transform by input transform. So here output is V0s and input is VIS. So transfer function is equivalent to V0s by VIS, and this is equivalent to 1 by LCS square plus RCS plus 1. Okay, so after rearranging this term, we can write V0s by VIS equal to 1 by LC divided by S square plus R by L into S plus 1 by LC. Okay, so this is the transfer function of this electrical second order system. Okay, now see, if we compare this equation, that means 2.77a equation, with our standard second order equation, that means this equation. So if we compare these two equations, we can write omega n square equal to 1 by LC. So from this we can write omega n equal to root 1 by root under L into C. Okay, and 2 zeta omega n is equivalent to R by L. Okay, so from this we can write zeta is equivalent to R by 2 into root under C by L. Okay, so if we compare these two equations, that means this electrical RLC circuit, that means the transfer function of this RLC circuit and the standard second order equation, then we can write omega n equal to 1 by root under L into C, and zeta is equivalent to R by 2 into root under C by L. Okay, now come to our mechanical system. Okay, so see, this is simple mass spring damper system. So if we apply Newton's law in this mechanical system, we can find this equation Ft equal to m into d2xt divided by dt2 plus f into dxt dt plus kxt. Okay, now after applying Laplace transform of this equation, we can write Fs equal to m into s square xs plus Fs into xs plus k into xs. So if, now we find the transfer function. So for finding transfer function, we need output and input. So our output is xs and input is fs. So output by input, that means xs by fs is equivalent to 1 by m s square plus fs plus k. Okay, so after rearranging this equation, we can write xs by fs is equivalent to 1 by m divided by s square plus f by m into s plus k by m. Okay, now again if we compare this equation, okay, not 2.77b equation, the above the 2.77b equation, that means this equation. So if we compare this equation with our standard second order equation, we can write omega n square equal to k by n. Okay, and from this we can write omega n equal to root under k by m. Okay, and 2 zeta omega n is equivalent to f by m, and from this zeta is equivalent to f by 2 omega n m. Okay, so from this we can write zeta equal to f by 2 root under k into m. Okay, so see, here we compare the transfer function of mechanical system and electrical system with the standard second order equation, and from this second order equation we can find omega n equal to for electrical system omega n equal to 1 by root under LC and zeta equal to R by 2 root under C by L, and for mechanical system omega n equal to root under K by M, and zeta is equivalent to F by 2 into root under K by M. Okay, now see, here we have taken one term in this equation, we have taken one extra term K dash. Okay, so here K dash is equivalent to 1 by K. Okay, why we take K dash? Because we make this numerator is equivalent to K by M. Okay, that means we want to, that means here numerator is 1 by M. Okay, so to make this 1 by M is equivalent to K by M, we have taken extra term K dash. Okay, so here K dash equal to 1 by K. Okay.